Guys, we're going to be doing an example on chapter 14 now. Emily asked me a question about comparing two means. Link to ask my instructor, which other people should be sending similar questions to me via that method. And also, again, to remind you again that there are videos that really describe the theory and concepts much more detail than my. Okay, we have two groups of numbers, and we want to answer statistics. Okay, so I guess she filled in some of the answers already. We want to compare two averages, and that's going to be a two-sample t-test because we don't know the sample standard deviation. I mean, we don't know the population standard deviation. We only know the sample value. The null hypothesis is that the average of the T group, I guess taxable, tax-free. What is that? What's the M? Municipal. Taxable and municipal. Well, usually we write it as UT equals UM or MUM, but if you subtract them, you get the same idea. And the alternative is not equal to zero. There's no direction here. The randomization is satisfied because the samples are random, randomly selected. The normal condition is satisfied because the taxable is nearly normal, and the let's see, and the municipal bond fund is nearly normal. I guess you have to create a histogram of that, which we could do in a couple of minutes. And the independent group assumption is satisfied because we're using what's called the independent t-test, because there's also something called a dependent. This is the IN independent. These numbers have nothing. The two groups of numbers have no pairing, like husband and wife would be an example of dependent. And now they want to figure out the actual calculation. So let's go to the data set, open a StatCrunch. These are the two sets of data. Doesn't have to be the same number of numbers. Let's take a graph. Let's take a histogram to verify that it's normal. Look at both of them again simultaneously. Let's just see what happens if we don't do any options. Compute. Yeah, I would say it sort of has a bell shape, a little bump in the middle, tails off at the end. It's nearly normal. If we grouped it differently, we might make a better picture. Let's see what we have here. And this is the other one. It's even more normal. So the answer will be, in all cases, nearly normal. Now let's do the two-sample t-test. Stat, t-stat, again, because we don't have the population, which is most of the time we don't. We have two samples, and we have with data. Select the column. Taxable is one group. Municipal is the other group. We want the pooled variance. That has to be checked. We want the hypothesis testing that it's equal to zero versus not equal to zero. And we compute. And they want us to tell you that the test statistic, which is the t statistic, is 1.19. That in there. Check it. And it's correct. The p-value is also done for us. No formulas. Just silently. 0.24. The fact that it's bigger than whatever the alpha is, 0.05. It's a big number, means there is no real difference between it. Check the answer. Correct. Is there a significant difference between the two groups? Use alpha 0.1. It appears that there is no difference, because there is insufficient evidence to reject the null hypothesis. If this number here would have been less than 0.10, then the answer would have been there is a difference and there is sufficient evidence, but it's less than 0.10. And we're done here.